Hello world, my name is Marcus Jones and welcome to another edition of a PowerPoint About. Today's episode will be a PowerPoint about two services that provide behind the scenes support that's vital for continued business operation, and these services are DNS and IMAP. When you get on the internet and search for a website, you simply type in the name of the desired web address, press enter, and the site is fetched. This ideal and seemingly simple process is powered by DNS, and most people are unaware of what's actually going on behind the scenes. Domain Name System, or DNS, is often referred to as the phone book of the Internet, or in more modern terms, a contact list in a cell phone that assigns specific names to the numbers that are stored inside of the phone. When the Internet was in its infant stages, people were able to match specific IP addresses to specific computers. But as the number of users began to grow, along with the number of IP addresses being used, people wanted an easier way to search for a website or a computer instead of remembering an entire IP address, and thus DNS was created. DNS is used to match IP addresses with specific domain names. For instance, while the IP address for a website may be a long number around 10 digits, the DNS is able to simply translate that IP address into a name such as google.com or any other web address that a person may search for. Now that we've explained what DNS is, naturally the next question to answer is exactly how does DNS work? When DNS requests are made, there are specific DNS servers used to locate and fetch the requested web address. Computers on the network are pointed at a particular DNS server, which can be provided by a user's Internet Service Provider or ISP, or a user's organization may choose to create their own DNS server to ensure all of their domain names are stored on the same secure DNS server that they have established and configured themselves, or to use a third-party service for added security outside of the ISP DNS servers. When a user searches for a web page, they type the name of the site in their web browser, press the search button, and voila, like magic, the website appears. Of course, there's a process behind this magic, and when loading a web page, there are different DNS servers that play a part in this process. The DNS query process begins with the recursive DNS server. The recursive server can be seen as a librarian helping to look for a book. It begins the initial search once a user types the name of a website and clicks search. The recursive server begins checking other servers in order to locate the DNS record for the domain name, which will provide the IP address. The next step in the DNS query process is the root server, or root name server. The root server can be seen as a sign that leads to a genre of books in the library. Once the root server receives a DNS query from the recursive DNS server, it will search for the correct top-level domain server, or TLD, to find where the domain name is located. Top-level domains are .com or .net that follow the domain name of a website, and can be seen as a specific bookshelf written by the author that you are looking for. And once the correct TLD is located, all of the authoritative name servers within the TLD are searched in order to find the correct domain name. The final steps of the process is the authoritative name server. The authoritative name server can be seen as the actual location of the book that you are looking for. This is where the actual information is located for DNS, and the destination that the recursive server must contact in order to properly match the domain name to the IP address. One function that helps expedite the DNS process is DNS caching. Many users visit the same websites over and over. Part of their daily habits are to visit the same websites and complete the same task, and DNS is able to simplify the lookup of recently viewed websites by using DNS caching. DNS caching allows a web browser or operating system to store DNS resource records, which have the required information gathered in the DNS query process. By using DNS caching, the server does not have to complete the query process over and over when visiting a familiar website, and therefore the speed of returning the appropriate web page is increased and simplified as the information is available via the DNS cache. As we've discovered, DNS is extremely important to the internet process. And with no default security settings, properly securing the service is very important. There are steps that can be taken to harden DNS, and one of the first things administrators should start with is by limiting the amount of access to the service. Administrators should be sure to manage access to the DNS servers by only providing access to admin users. An organization can ensure that DNS servers are secure as possible. The fewer people that are able to access the servers ensures that there will be less of a chance that they are compromised. Controlling access to the DNS registry and file system will help add a form of security to the service as well. Another thing that administrators can do to harden DNS is to use DNSSEC. Domain Name System Security Extensions are used to provide security to the DNS by using digital signatures to make sure that DNS data is encrypted and secure in a way similar to how HTTPS is used to secure HTTP connections. By adding this extra layer of security to DNS, administrators can make sure that connections are trusted in the communication between DNS servers. While DNS creates the magic of providing internet connections, the next service that we will discuss seems as though it may have a bit of magic involved with this process as well. But just like DNS, there are many working parts in the background that make this service work. The service that we will be covering is IMAP, or Internet Message Access Protocol. IMAP is used by mail user agents, or MUAs, to retrieve mail from the mail server. IMAP works in concert with SMTP to complete the email process, with SMTP delivering the messages to the server and IMAP retrieving them. When a user establishes email on the server, they are given a choice of two different internet mail protocols, and ultimately, these two protocols decide how you would like to access your email. The two mail protocols to choose from are, of course, IMAP, but also Post Office Protocol 3 or POP3. POP3 is an older way of retrieving messages from a web server in which users will download all of their email messages to a specific device and may only be able to access their email files from that device. There are some advantages to using POP3 over IMAP, the main reason being for security reasons because all emails are stored on just one device, but outside of that, there are many more advantages to using IMAP. IMAP was created with modern computing in mind and allows users to access their email messages no matter where they are and to be able to do so on multiple devices. IMAP performs the task of mail protocol by acting as a middleman between the mail server and email clients such as Gmail or Outlook by going to fetch the mail from the server and returning it to the email clients. IMAP allows users to access their email messages without having to actually download them to their computer, unlike POP3. Instead, IMAP enables the ability to simply read the email messages off of the server and only download them if needed. Allowing users to do this adds extreme convenience for the mailing protocol and is the reason that many people and organizations choose to use IMAP over dated POP3. Being able to access email on a computer other than the one using at work or at home is a large benefit because users can actively access, read, and create email messages whether they are using their main computing device or a different one. Properly hardening IMAP is very important and can be the difference in preventing a hacker from accessing email accounts as well as servers. The first thing that administrators can do to harden IMAP is to control the number of users who have access to the service. By properly assigning duties and making sure that only root or admin users have access to IMAP, organizations can help mitigate the human error element of potential IMAP issue by limiting the amount of users with access. By doing this, the space for error is reduced due to only a few trusted administrators having access to the service. Another thing that users can do to secure IMAP is to use IMAP Secure or IMAPs with an S. IMAP, like many other computer protocols, was not created with security features installed, and the service uses unsecure port 143. In order to use IMAP with a secure connection, administrators should instead use Internet Message Access Protocol Secure or IMAPs using port 993. And similar to the way that SMTPS secures SMTP, this port encrypts the mail protocol using an SSL layer. Using port 993 will ensure that all messages being retrieved by IMAPs are encrypted in the case that there is someone eavesdropping on the server or if the server is possibly compromised. One final step that administrators can take to secure IMAP is to make sure that the server cache or history is cleared periodically. Since IMAP stores messages on the server, it is important that system admins occasionally clear the server history to ensure that older emails do not stay lingering on the server and potentially becoming an area of risk if the server were to be compromised. Clearing the server cache will also help system admins clear memory space on the server by removing any old or unwanted messages. All of these ways can help secure IMAP and streamline the mail protocol process. Thank you so much for watching my PowerPoint. This was a PowerPoint about DNS and IMAP. My name is Marcus Jones. These are my references, and goodbye, world.